Yes, sir.
Okay, let me start. So, may I request all of you to mute yourself? Okay. So, please mute. Now, as I discussed in the last class, so these are the topics will be covered by three faculty members. So, today I like to start the introduction to the mechanism. And yesterday I just mentioned that this particular subject is the most fundamental subject in respect of machine design, and we have introduced what do you mean by design, or more specifically the machine design. Machine design is the subset of mechanical whole mechanical design, and design is the process of problem solving. It is the decision making process. You have to take decision based on some law of physics or some other engineering judgment. Design is an iterative process. That means it is not straightforward. It means once you can complete your design process, it's never possible. And design is an innovative and creative process. An objective of the mechanical engineering design or mechanical engineering designers is to design and develop the product. It may be device, machine, or mechanical system that is functional, safe, reliable, usable, and manufacturable, competitive, and marketable by applying the various scientific principles. And in this particular class, you learn that scientific principles which is required for machine design. Now, I just mentioned yesterday that the identification of the needs is the very fast step for the design process or the design of any new product or development of any new product. And I have mentioned here that one example here that you see the Bharat Ratna Sachin Tendulkar, he is in front of the machine that you have identified is the bowling machine. Now, why the bowling machine is required for that greatest batsman that you have already identified yesterday? Few more. I just uh, jot down that whatever you have mentioned. So one thing that in the year 1994, 95, at that particular time, Sachin Tendulkar has to face the fastest bowling in this world. So that time, fastest bowler in the world was the your Brett Lee from Australia and Shoaib Akhtar from Pakistan, and their bowling speed is 160 kilometer per hour around that. And as you know, the Sachin Tendulkar is a so dedicated player that he can practice. He used to practice such type of bowling before facing any international game against these two bowlers. But in order to practice the 160 kilometer per hour bowling speed, you should have in India physical bowler. Getting that physical bowler is very difficult because you know at that particular time instant our fast bowler was Venkatesh Prasad, and it's long back. You may not know his bowling speed, but I can tell you his bowling speed is slightly higher than our Anil Kumble's bowling speed. Anil Kumble is one of the renowned spinner in Indian cricket. So our first bowler bowling speed is slightly higher than that. So by practicing that such type of 130 kilometer, 135 kilometer per hour bowling speed, it is very difficult for this greatest batsman to face that bowling speed. But that time machine can help. If you set your parameter of a machine, then it can bowl 160 or even more than 160, and it can deliver consistently that particular speed. But no physical bowler can deliver consistently that such a speed. But machine can do if you can set parameter fix. This is one application of the bowling machine. Second application I'd like to show that also your friend has been mentioned that if a particular batsman say weak in a leg side ball, so In order to rectify his flaws, same kind of ball has to practice in net session. And as you know, no physical bowler can consistently deliver the such type of ball to rectify the weakness in leg side, but machine can deliver. So that way, in order to rectify a particular shortfalls of a batsman, machine can help. Now, in the current context, in the age of era of T20, you just see nowadays there are the more requirement of all-rounder than the specialist bowler or the specialist batsman. Now, those who are bowler, they has to bat also in the situation will come, then he or she has to bat. The bowler has to be bat. So, but naturally, the bowler are naturally talent is the bowling, and they basically getting very less chance to practice bat in the net session because they are the bowler. The means naturally they are the bowler, but bowler can use this machine in his home so that without another bowler, the bowler can practice batting in his home because the machine can automate it properly. If you can use remote control, then it can deliver the ball one after another, and bowler can practice the batting, and bowler becomes the all-rounder. So this is another advantage of using machine. Now, once you identify the needs in this way, then you have to find out, you have to do, you have to formulate what you have to do. For example, in our institute, there is a student activity center. Suppose we don't have any bowling machine, but there are the many students, they are interested in cricket. Now, if you think of that, instead of purchasing a machine, if you like to develop your own machine, then first you have to check whether it is feasible or not. Now, I like to give an example here. The bowling machine, what I have shown here, in the year 2003, its cost was around 4 lakhs. It is imported one from UK. And at that particular time instant, 4 lakhs means today's it becomes much more, but price has not that much increased, but that particular time it was in 4 lakhs. Now it is very difficult for the small club or the school or college to afford that much of money of 4 lakhs. Now, obviously, if you can develop an indigenous product with a low cost, then it will be economically viable. So in this way, the economically feasibility study you have to carry out. And at the same time, you have to carry out the technological feasibility. So techno-commercial feasibility study you have to carry out by collecting relevant information, design information through the market survey, through literature survey. Now you have to formulate, or you have to state your problem statement, or you have to frame your problem statement according to your need. For example, in SAC, you want to you have some limitation in your funding, so you just like to design your own machine. Then how will you define that one, or how the problem statement will fix? Obviously, your problem statement will be design and development of low cost bowling machine, because we don't have that much of fund. So it should be a low cost bowling machine. If it is 50,000, it's good enough. Even if it is 80,000, still it is affordable. So design and development of low cost bowling machine, and along with that, I like to add here, you just see the bowling machine has been placed at a height. If you see the compare with the Sachin Tendulkar side, it has been situated at around 7 feet or 7.5 feet or 7 feet around, and that particular height. And you have to keep that particular machine and that height. As it is the ground, you see the leg portion or the stand portion you can remove, and you keep the bowling machine in your coaching camp. That means every time you have to lift up that machine at a 7 feet height, and you have to put over the stand. You have to keep over the stand. From there, it is obvious you have to develop a relatively low weight machine. That means portable. So that is why you define your problem in this way: design and development of low cost portable ball throwing machine. Or more generic way you can also do, if you have fun, then it might be a multi-purpose ball throwing machine. Same machine can throw the cricket ball, tennis ball, hockey ball, like that. So this way you define your problem. Once you define your problem, then you have to draw certain specification, task specification or performance specification. Now, how do you specify a machine here? For example, if you like to purchase a cell phone or a laptop, then you have to specify, though it depends on the how your pocket size is, but still it is you have to specify certain parameters. For example, cell phone. So you have to specify RAM, whether you like to take the 6 GB RAM or 8 GB RAM, that you have to specify. Internal storage, whether you like to take 64 GB or 128 GB or 256 GB, now you have to frame your specification. Similarly, the battery life, battery milliampere hour, whether you like to take the 5,000 or 6,000 milliampere hour, then you have to specify. And that obviously you check it with this. And another important nowadays is the camera, front camera and back camera, how much megapixel you like to want, and accordingly cost will increase. So that is why depending on the availability of the fund, you have to specify your cell phone. Similarly, in the bowling machine also same thing. Now obviously bowling machine specification will be different from the cell phone. In case of a bowling machine, most important parameters or most important specification is the bowling speed. So minimum bowling speed, maximum bowling speed, and how it will change. Let us say the minimum bowling speed you just choose in the 50 km per hour, whereas the maximum is highest one is say 145 km per hour, because it is used in for NIT Durgapur student. So they may not interested to practice the 160 km per hour bowling speed, is the relatively much higher speed. So and if you like to increase the speed, then cost will increase because your motor power has to be increased. So that way, a bowling speed you just fixed it, and also the increment, whether you increase 50 kilometer to 145 kilometer by 1 kilometer increment or 2 kilometer increment or 5 kilometer increment, you like to increase that, you have to specify. Now, ball size, type of the ball, how much power has to be consumed. So these are the parameters or specification you have to draw tentatively. And obviously, the keep in mind your cost. Say, let us say 80,000. Next step is a very important step for the mechanical engineer, the conceptual design. So design conceptualization. Now here, what you have to do, you know your problem. Your problem is to design a ball throwing machine, that means, or bowling machine, and that means a ball throwing machine. You have to design a mechanism by which you can throw the ball. Now here is the job of designer, or those who are mechanical engineers job, purely mechanical engineers job, how to throw the ball, by which mechanism you can throw the ball. Can anyone suggest, because this particular point you have to do brainstorm, you have to do brainstorming, because it's the design thinking. So conceptual design here, number of ways you can throw the ball or you can hit the ball. So can anyone tell from your common sense what could be the possible mechanism or possible way you can throw the ball or you hit the ball?
So we can use
So,
two rollers up and down, and in between we can put a ball, just like that.
and sir, there can be
We
also
can
another
even use
method,
air pressure,
like
right?
we can rotate the ball about a center pivot and then release the ball at such when a particular speed is reached. And
Uh,
from the
okay,
formula that mv square is equals to r, we can formulate the velocity with which it will be released when we will
okay,
release it from a particular holder type.
okay. Both concept is good. Any other concept?
So we can use a spring system.
A spring system, good. Any other concept? Because the brainstorming session, this type of brainstorming session you have to do among your peers, among your friends. That it's many mechanism can thought of because some mechanism will come to your mind, some other mechanism will come to others' mind. So you just any other
Sir, we can use
concept?
collision.
You like to hit the ball,
Yes, sir.
but how?
Uh, mm,
Sir, I was thinking of a way to create an air pressure channel and then pressurize all that air and hit the ball with it.
Possible?
Sir, we can use gunpowder.
Gun fall. Good.
We can
Good.
So what
That's-
about like two shaft and the ball is in between? So at a particular point, there'll be more pressure and it gets shot out.
Okay, sure, it's possible.
Sir, we can convert the rotational motion of the motor into rectilinear motion and then we can hit the ball.
Okay, that's also another good idea. So in this way, you just can you see the
No, sir.
PowerPoint? Can you
Yes, sir.
now in this way you your design conceptualization or through brainstorming, through design thinking, you can jot down your mechanism by which you can throw the ball. So a lot of innovation is required. So this part is the intellectual part. There are a lot of innovation is required. Now, once you jot down, these are the way you can throw the ball. This is the concept. Now you have to see scientifically, you have to check, or from practically you have to check that whether all mechanisms are feasible or not. For example, spring is a good idea. But problem is in spring, every time you have to compress the spring, you have to put the ball and release the spring, it will hit the ball and it will throw the ball. Now, as you know, the spring, if you number of time you compress and expand, compression, expand, due to fatigue, it fail maybe after delivery of 500 balls. And spring is the main machine element by which you are applying the force. If it has to be changed after 500 ball, then it is economically not feasible. So that is why, so it may not be you cannot develop the machine which can be commercially viable if you use the spring. So that way you have to you may discard few concept and you have to or more you have to do more analysis over the few feasible mechanism. And that part, as you know, that how much force you have to apply over the ball and how you will transfer that force from one source to other. So that is big issue. So for example, somebody mentioned the shaft has to be rotated by motors. Now how much RPM is required, how much the gap is required, that all these things calculation is required. Similarly, somebody mentioned collision is like whether it is by spring or by means of pneumatic or maybe by means of a hydraulic cylinder, you hit the ball. Now once you hit the ball, that means your one chapter in physics is the collision. So from there, momentum transfer equation you have to apply and you have to check how much force you have to apply over the ball, because ball weight, size, everything is known to you. That means you have to apply the physics to model that process, and that is called the modeling simulation. So you synthesize the mechanism that you have already synthesized, like means you have already mentioned that either it is two rollers or it may be the spring loaded or it may be the pneumatic cylinder, gun type. So this way you have synthesized or conceptualized the mechanism, then you have to apply your concept of physics, a law of physics, to analyze its motion, whether you are getting proper motion or not. So in this particular area, you have to apply the law of physics, and that you will learn in this particular chapter. So in this particular top A class, you will learn this particular portion. So once this modeling simulation is over, then you have to carry out some optimization to find out which one is the best one, then select, then go for the design evaluation. It is the iterative process. If you found any mistake, then go back to again conceptualization. Once your design evaluation from the different aspect, from the cost aspect, from the safety aspect, evaluation is over, then you go for the detailed design analysis, and after that you have to prepare the documentation, design documentation for fabrication. Now in this particular class, our focus is on this particular area: modeling simulation. First is the design conceptualization, synthesis, and the modeling simulation. So in order to do that one, another way, I don't know whether it will work or not. Let me check. See, the another way you can throw the ball. Yeah, somebody mentioned also. So it's also a mechanism. Now, the general steps involved in machine design, as I mentioned yesterday, that first you have to solve the kinematics. If the moving bodies exist, if the body is stationary or link is stationary, then you have to solve static. And what are the what you will get from this particular analysis? From static, you will get the external load. How much external load is acting? Now, kinetics, you can find out that how much external force is required or external load is required. It may be force, may be torque, in order to get the desired kinematic parameters or desired motion parameters. So first you have to solve kinematics, then that motion parameter fed into the kinetics. From kinetics you will get the how much load or how much force or torque is required to get that desired motion characteristics. Once you know the force, then that will be the input for your internal effect analysis, let us say stress analysis. And using the stress analysis, you can find out what could be your safe cross-sectional dimension of a chosen geometry. So whether your cross section will be circular, rectangular, I section, that is your choice. And you have to do systematically number of times, you have to check. But what could be the size of a chosen geometry, that you can find out through the analysis, through the internal effect analysis, for example, stress analysis. And this is the steps for the machine design. And I like to tell you, this is a well-known mechanism. This is called the slider mechanism. I will come into this slide. So the steps why I like to show you. So in this particular class, we'll cover kinematics and kinetics portion. In your solid mechanics class, stress analysis will be covered, and force. Once this foundation is over, then the fourth semester you will learn how to design machine. Now, your subject is theory of mechanisms and machine. I already mentioned, it is the applied science, and it is used to understand the relationship between the geometry of your object and the motion of the parts of a mechanism or a machine, and also to estimate the how much load required to produce this desired motions. So this is the objective or the of this particular subject, theory of machine and mechanism. In other words, it is the study of relative motion between the various parts of a machine and the study of forces that act on those parts. So what could be the learning objective? Learning objective is to provide engineers the necessary tools, or you have to give exposure to the necessary tools which can be systematically synthesize the system, which means scientifically you can arrive at the best possible configuration of the mechanism, and you can find out the certain dimension, not all, that dimension here is the kinematic dimension of the bodies constituting that particular system. So this is the, keeping in mind this learning objective, we like to start here the fundamentals of mechanism or the building block of a mechanism. For example, if you like to see the room where you are sitting now, so can you tell me what is the building block of that particular room? So how it has been fabricated or manufactured in your room only? Can anybody tell what are the building block or the element by which your room has been fabricated or manufactured or built?
Slabs and columns.
Columns are there. Then wall is made of.
So bricks and cement, brick and cement.
Your walls are made of bricks. Brick is a building block. Brick is one building block. And now the bricks are only bricks is there. If you can stack bricks, is it will be your home? Huh?
Cement. Big stones are there.
So there will be a mixture of the cement, sand, water, mortar.
Yes, sir.
So that will create binding or join between the two bricks. So one by one you join the bricks and you will get your wall structure of your home. Similarly here also in mechanism, building block of a mechanism is known as a kinematic links. So building block of a mechanism is the kinematic link. Now you just see this one. Look it carefully. This is a well-known mechanism which is used in your IC engine. That means the engine used till date before electric vehicle. It is petrol or diesel based engine. This type of mechanism is used. This is called slider crank mechanism. Now, building block of a mechanism is the kinematic links. Here, how many parts has been used? You just see through animation I have shown already. You can see three moving parts. Three moving parts, but the shaded one is also there. That is the fixed one.
Yes, sir.
The three parts you can see that is the moving parts, but there is that S color shade on which it is translated. That is the fixed one. So, how many links?
Yes,
Then 4 links.
4 links.
4 links. Now, what do you mean by links? It is the most fundamental question. What do you mean by links? So each part of a mechanism which has relative motion to some other part, that is called the link. A link may consist of number of small elements, but it do not have any relative motion between the small elements. So a particular link have a relative motion with the other links. That means a particular part of a mechanism which have some relative motion to other part, then this two part is called the links. Okay, this two part is called separated this links. For example, here, so this part having the relative motion with this one, so these two are the links, two separate links. Now this particular mechanism, slider crank mechanism, I have shown here. One second, I will come. So what are the different types of links? And links maybe I like to show you here first. Links are either rigid or flexible, or it may be fluid. So there are the 3 classifications. Rigid may be links may be rigid. So rigid means elastic, basically resistant body. It is assumed that it is not undergo any significant deformation while transmitting the motion. So that is the rigid links. Example, that slider crank mechanism or any mechanism that you have seen in the automobile that made of rigid links, cam follower, gears, and connecting rod, all are the rigid links. There is a flexible link also in your mechanism. So flexible link is one which is partly deformed in a manner not to affect the transmission of motion. For example, belt drive, chain drive, they are considered a flexible link. There is a fluid links also, fluid coupling. So it is deformed by having fluid in a closed vessel and the motion is transmitted through the fluid by pressure. So out of these 3 types of link, in this particular class, we restrict ourselves within the rigid links. And rigid links are 3 types. Rigid links are different types, like singular links. Singular links means the link which is connected to one other link. Binary link means a link which is connected to 2 other links. That is called binary link. Ternary links means the link connected to 3 other links, and so on. Now, in order to connect this one, you just see here, let us start with the binary link. So binary link, this is the example of binary link. So this one is example of the binary link. Now binary link having the 2 node points. That means in this 2 node point, other link can connect. In case of a ternary link, 3 node point. This each node point you can connect another link. So that is why it is called the ternary link. And a link, if you have a 4 node point, then it is called the quaternary link and so on. But most of the times mechanism design we are using binary link or ternary link. There is another link that is called the singular link. In case of a singular link, it is connected only one other link, that is only one node point. But where you like to use singular link and where binary link, that I like to explain just afterward. So next is the links. Only links, like links just like a brick, single brick. But now link has to be connected to form a pair. So the next is the kinematic pair. So links are joined by or connected through a joint. So kinematic pair is the joint of 2 or more links and it having the relative motion between them. So when 2 links are connected through a joint, it forms a kinematic pair. Now what are the different types of kinematic pair? According to the nature of contact, kinematic pair are the lower pair and higher pair. Lower pair means surface contact with the one link with the other link, having the surface contact or area contact. Whereas higher pair means line contact or the point contact. So in case of a lower pair, there will be a surface contact or the area contact, whereas the higher pair either point contact or line contact. Now example you just see. Here you just see, in this particular example, this is the well-known slider mechanism. The slider will move over the a cylinder. Okay, like the slider means piston, it move over the cylinder. Now it is the area contact or the surface contact. So that is why it is lower pair. Or one link will rotate with respect to other link. Like say here, one link is rotated, then it is surface. If you see here, it will get this surface contact. You know, this side inside surface contact. Here also you just see whole thing inside is the surface contact. So that is why these are the example of the lower pair. But higher pair, for example, ball bearing in your cycle. Cycle, you see the ball bearing. Ball bearing, you just see ball. It is a spherical. Over the surface there will be point contact, or if you see the gear, so there will be gear, the contact line contact along a particular line teeth are in touch. For cam follower, I will show you that also be either line contact or point contact depending on its design. So they are the example of higher pair. So example of higher pair is ball bearing. Your gear drive, 2 teeth are basically in touch in a line. Another is the cam follower mechanism, that is also example of a higher pair. Lower pair means surface contact, and different types of lower pair. A lower pair again classified according to the nature of relative motion. Here I have shown. It may be the prismatic or sliding pair, turning or revolute pair, screw pair, cylindrical pair, and spherical pair. Now your sliding or prismatic pair name itself says this particular, they are the 2 links. Say link number 1 and this is the link number 2. Now link number 2 will translate like this with respect to link number 1. With respect to the link number 1, link number 2 will translate. So that is why it is called slide, translator slide. That is why it is called sliding pair or prismatic pair. Now turning pair or revolute pair. Here you just see with respect to this axis, this particular, this is the 1 and this is the 2. So 2 will rotate with respect to 1. Is it clear? So link number 2 will rotate with respect to 1 about this axis. So that is why it is turning or revolute pair. Screw pair, you see, we all are used out of the screw nut mechanism or the threaded joint. So here, if you can rotate the nut, then nut will advance in the forward direction when screw is stationary. So that is the example of a screw pair. Cylindrical pair means here the difference is here both rotation and translation is possible. So with respect to 1, 2, 1, 2 will translate as well as it can also rotate. So both rotation and translation of the link number 2 with respect to link number 1 is possible, and that is what is called cylindrical pair. Spherical pair is the basically sphere, is the spherical joint. You might seen in the automobile, in your either two-wheeler or four-wheeler, mirror is placed over a spherical joint. You can rotate about x-axis, you can rotate about y-axis, and you can also rotate about z-axis. So this will basically known as spherical pair. Now the next is, once the kinematic pair, there are many other pair I like to tell you. Before that, I like to show you here. You see that I have shown in this case. First is the kinematic link. So when kinematic links are connected through joint, it forms a kinematic pair. Now series of kinematic pairs forms a kinematic chain, and in the kinematic chain, if one link is fixed, then it is called the mechanism. Okay. Now in this case, you just see, you have already identified how many links it having. See the video, at the same time see this particular, both it is the, you can say schematic diagram or line diagram of this particular animated slider crank mechanism. It is very well known mechanism. Now how many link you have? Can you identify how many you have already identified? There is a 3 movable link and 1 ground link, that is the fixed one. Then the total number of link is 4. So you just see here that this one, the S color, this particular thing is basically ground link or link number 1. Now link number 2, that means this portion. Link number 2 means this particular portion, that this one. This one is the link number 2, that is the rotating. So this is the link number 2. It's similar to here, this one. Now link number 3 is this one. That means it is connecting rod. It is called the connecting rod, this one. So link number 2 is called the crank. This is called the connecting rod, and this one the slider. This one is the slider. Here it is link number 4. So total number of links are the 4. 1 is fixed link, 2 is rotary link, 3 movable link, 3 is movable link, 4 is also movable link. Now just see, in between link number 1 and link number 2, what type of joint it has? Can you identify in between the link number 1 and link number 2, what type of joint? You see the motion here, then you can easily identify. In between link number 1 and link number 2, this is the joint.
Spin joint or knee joint?
In respect of this motion, you just tell me, in respect of relative motion, use this terminology.
Sir, turning or revolute
Revolute or revolute pair. It forms the revolute pair or turning pair. In between 1 and 2. In between 2 and 3, you just say in between 2 and 3 also join this one. In between 2 and 3, what type of? You see, look at video carefully, you can easily understood. It will be again?
Revolute pair.
Revolute pair. Now just see, in between here, in this particular point, here the spin is there. Now it is similar to here, in between 3 and 4. In between 3 and 4, is there any joint?
Yes, revolute.
Sliding.
In between 3 and 4, is it
identified? Oh, revolute
joint. Again revolute joint. Otherwise it will break. Now just see this particular slider. You just see the black color slider. It will slide over the S color, no fixed frame.
That is sliding.
Straight line. That means this one is the sliding pair in between 4 and 1. That means from here you can easily understood, in between 1 and 2 pair is revolute. In between 2 and 3 links the pair is revolute. In between 3 link number 3 and link number 4 revolute. In between the link number 4 and link number 1 is your sliding pair or the prismatic pair. So how many pair then?
4.
Total how many pair?
4.
4 pair. That means 3 rotary, that means revolute, 1 prismatic or prismatic or your sliding, whatever you call. Slide. Now, what type of link it is? Can you identify link number 1? Let us say from the link number 2. What type of link it is according to this classification?
Binary.
According to this classification, link number 2 is
Binary.
binary. Link number 3 is
Binary.
link number 4 is
Binary.
link number 4.
Singular.
Binary.
Singular.
See carefully. Link number 4.
Singular.
Link number 4 is connected to how many links?
Only one.
How many other links?
Only one.
Link number 4 is connected to how many other links?
2.
2, because link number 4 is connected to link number 3 through reverse pair, and link number 4 is also connected to the fixed link, that means link number 1 through sliding pair. Is it okay?
Yes.
Okay.
So link number 4 is also binary, and link number 1 link number 1
Singular.
why?
So because it's only connected to sliding.
No, it is connected to how many links? Link number 1.
Sir, binary.
One.
Sir, 2 binary.
One is two.
Link number 1 is connected here with the link number 2 through reverse pair. Again, link number 1 is connected to the 4 with the prismatic pair. Then that means it is connected to how many links? 2 links. That means your link number 2 is binary, link number 3 is binary, link number 4 is binary, link number 1 is also binary. That means all 4 links are binary. And remember, this is called the closed kinematic chain, and closed kinematic chain links are, please mute it. So I request you please be muted. Now here all links are binary, and you remember closed kinematic chain, all links should be at least binary or higher. There is no use of singular link in your closed kinematic chain. Now what do you mean by closed kinematic chain? That I will tell you, just wait. Now again, another classification which is also important, that is the type of kinematic pair or type of joint. According to the physical closure of the joint, it may be form close or it may be force close. Form close means if your joint is geometry is such that no external force is required to the joint, the two link of a member, two link in a particular joint, it is in contact. It remain contact because of this geometry. But there are some joint where the two links are in contact due to the application of external force. That is called the force close. So that example I will have shown here, force close, spring loaded thing, that I will show you the video that time, you can easily understood this one. Now another classification is according to the number of link joined to a particular joint. A joint may be revolute joint or prismatic joint. This is one issue. Another is a particular joint, how many links are connected. For example, here this is the joint, pin joint. That means the revolute joint. The two links are connected. One L1 and L2. Here two links are connected. But say another pin joint, you see how many links are connected? 3 links. 1, 2, 3 links are connected. So these two joint categories is defined as the first one. This one is the first order joint. This one is the second order joint. Or some book it is called binary joint and ternary joint. So you don't confuse with the binary links with the binary joints. Two different terminology. If you have any confusion, then in case of a joint, you use the term first order joint. So according to the number of links connected to a particular joint, the pair or the joints are classified as a first order joint, second order joint, third order joint, and so on. Now order of joint is defined as number of links joined minus 1. You see 2 links are connected, 2 minus 1 is 1, that is a first order. 3 links are connected a particular joint, the order of joint is 3 minus 1, that means second, 2. Got my point? So whether a particular joint will be first order, second order, third order, that depends on how many links are connected, because the order of joint equal to number of links joined minus 1. So that is the order number. So from that respect, this is first order and this is the second order and so on. Now I like to show you, I don't know whether, I like to show you that very basic mechanism in your theorem machine where all 4 joints, 4 links, 4 joints, and all 4 joints are revolute type. So please see properly. This is the most fundamental mechanism used in